Hi everyone, my name is Chris, and this is the project demo video for the Intel 8080 emulator project that we worked on for the summer capstone project. So a bit of background. So our team built an emulator using C language and assembly for the Intel 8080 processor, and the goal was to disassemble a Space Invaders ROM file so that users can play the game, and we also included some controls and graphics peripherals. So background about our team. So Hannah is from Texas. Her favorite programming languages are C and assembly language, and she loves doing lower level programming and computer architecture. My name's Chris, and I'm from California. And as for me, I'm not as strong, I guess, in C and assembly, so this is definitely a good learning experience for me during the summer. So what makes this interesting, this project? So for us, it was a good chance to challenge ourselves, to learn more about computer architecture, C programming, and assembly language. For the users, we thought it would be a pretty cool experience to play an older video game, and maybe for players who had gone to play this game when it came out, you kind of get a good feeling of nostalgia from seeing this, and also kind of appreciating how far the game industry has come the past 40 years. And finally, we got a chance to kind of maybe learn about older processors that might still be used in embedded systems today, such as the Zilog Z80, which I believe is still being used in graphing calculators such as the TI-84. So a bit of highlights about our project. So this is kind of the user interface. It's in the command line, and Hannah put together some nice ASCII art for this. So you kind of have like a game selecting screen, screen size select, and the controls. So yeah, this is kind of what the different screen sizes would look like small, medium, and large. And we also support multiple players for controls. The user can also choose between several different games that run on similar hardware to the Space Invaders game. So you have Space Invaders Part 2, Balloon Bomber, and Lunar Rescue. We also simulate sound effects by playing a wave file of the sounds when indicated by the game, and this is kind of what that sounds like. All right, so now I'll move on to a demo of the project. And apologies for that stuff in my terminal. But yeah, this is the interface from a couple of slides back. So I'll pick the Space Invaders Part 2 game, choose the large screen size, and then press S to start. All right, that was pretty much it for the demo portion. So now Hannah's gonna talk a bit more about the development process that we went through during the summer.
Hi, this is Hannah, and I'll be covering the next portion of the video. In terms of the technologies we used during our development. Hi, this is Hannah, and I'll be covering the next part of the video. So in terms of development and the technologies we used, the emulator was written in C because the language has the necessary features we needed to emulate the processor. We used Git as our VCS because that's the one we've had the most experience with in classes. And we used the SCL library because it made implementation a lot easier than it otherwise would have been. It also works across multiple platforms. Another technology we used was Jira, the Agile board, and this was really helpful. So as an example, you can see we have here a ticket about researching SCL, and Chris had really good documentation and would update with video clips, screenshots, and just any other relevant information. And yeah, so this was a really helpful technology during our development. So these were the steps that we took. We first disassembled the Space Invaders ROM from binary to assembly language. We created memory and CPU modules that would load the ROM into memory and perform emulation of various instructions. Then we handled interrupts that would have been sent by the video hardware of the original game. And then we implemented graphics, controls, and sounds using the SCL library. And at the very end, we created the command line interface and added support for loading additional games. So looking back at our development track, it does seem quite logical to me in that we had to implement a certain step before we could implement the next, because they all kind of built upon each other. So I will talk about our original plan and deviations. We had a pretty clear path to follow from the reference website, the Emulator 101 guide, but we decided to deviate a bit from their memory model. We implemented it differently for our own learning purposes. And secondly, our original plan was to finish the processor module by week 5, but since it was fairly complicated, we ended up completing it in week 6 and finished fixing the bugs by week 7. So the challenges we face include figuring out our Git workflow, but we managed to solve that pretty quickly. Implementing the instructions was complex at times, especially when it came to setting flags and parity operations. And debugging interrupts was also tricky. Me and Chris both kind of had a different way of approaching interrupts, and we ended up going with Chris's since his one worked a lot better. These are the lessons we learned. We definitely got a deeper understanding of processor architecture, project management skills, how to tie a lower level program with a higher level interface, and compilation of makefiles. So as you can see here, we have like multiple modules, and they're basically 3 layers, the memory, then the kind of processor layer, and then the machine layer on top of it. So that was a skill that we developed. So as a conclusion, we may extend the project, find some more ways to learn new things and develop our skills, and sharing it with friends and family, since kind of the original vision was to help people kind of relive memories if they were a child during that era and played this game, or help younger generations kind of get a taste of retro video games. And we may consider other similar projects as well, because this was very enjoyable and rewarding. Thanks for watching.